Hello everyone. So in this video record, I will be providing an in-depth overview of web scraping technique used for automated data collection from websites. And whether you are working to extract data from a specific web page or gather information from various sources, web scraping can be a powerful tool. And in this session, we will explore the fundamentals of web scraping, including inspecting web pages, understanding the general structure of URLs and HTML structures, utilizing XPaths, and even touching upon a bit CSS locators. So let's delve in and so when it comes to creating data, there are multiple alternatives available. One option is to access ready-made data from trusted sources such as World Bank, OECD, TÜİK, and more. And another approach involves using application programming interfaces provided by social media platforms, the developers of those platforms, and some other sources. And but in this session, we will only focusing on web scraping as a means of data collection. And additionally, there is one more alternative. Researchers also use advanced techniques like artificial intelligence techniques and machine learning models for data extraction. For example, in the Glocon database, we use newspaper articles to detect protest events using NLP methods. And what about web scraping then? So the process involves several steps inspecting the web page and HTML code. So before scraping a web page, it is very important to examine its structure and analyze the underlying HTML code. And so in this step, we understand the hierarchy of elements and identify the specific data that we want to extract, and setting the URL and downloading the HTML. So once we have identified the target web page, we need to set the URL to access it. And by sending an HTTP request to the URL, we can retrieve the HTML content of the web page. So cutting out the HTML, after obtaining the HTML content, we need to isolate the relevant parts of the HTML code, which contains data that we want to extract. And this often involves navigating through the HTML structure using various techniques, which we will see in a few minutes later. And extracting content step, so once we have isolated the desired HTML elements, we can just extract the content that we need. This might include text, tables, images, links, and some other specific data presented on the web page. So, and the final step, if we save the extracted data in a format suitable for further analysis. This could involve storing the data in a structured file format like CSV, JSON, etc., or directly inserting it into a database maybe. And then in the next step, here you see the general pipeline of Beautiful Soup library. I will in this session will use Scrapy, but also there are some other libraries. Beautiful Soup is one of them. And here you see the general pipeline of the library. We just request to access the web page, to take the HTML code, and then parse the HTML and find the relevant content using relevant methods under the library, and then we save our data. So what about HTML structure and URL structures. So understanding the URL and HTML structure is very important for web scraping. So URLs are composed of various components such as path, search terms, and parameters. And by manipulating these components, we can navigate to specific web pages and or perform targeted search. And on the other hand, HTML is a markup language used to structure the content of web pages, and it consists of various elements, attributes, and text. So elements can have relationships with their children, parents, siblings, and descendants, forming a hierarchical structure. And to illustrate this structure, you see an example, a sample HTML code. Here, body is children of HTML, and div is children of body. Body is parent of div. And in this div element, we have two different attributes like ID and class. So ID attribute of div element is div1, and class attribute of div element is class 1. So we also have siblings. So these two P's are siblings. And so here we have also a textual component of that HTML. So in this P element, we both have attributes and also textual part. And also for this P element, we have a data size textual part. And so there are here some HTML elements. Widely used HTML elements are can be found among those. For example, if you want to get access a table, probably you should look at those. Or if you are interested in links, they are often stored in these A elements. And yes. What about XPaths? So it's a language used to navigate through HTML documents, and it provides a way to locate specific elements or attributes within the document structure. And understanding XPath expressions is crucial for targeting the desired data. Here are some XPath symbols and conventions here. So single forward slash, for example, moves us one generation forward in the hierarchical structure. And if we use brackets, it specifies the order of the noted elements. Double forward slash, for example, instructs to look forward to all future generations in the among this hierarchy. And here you see an example. Yes, we have few examples here. For example, there is an XPath, which means go XML, HTML elements and one generation forward, body one generation forward, then go the second div element, not the first one. And in this element, collect all tables, whether they are first generation children or any descendants. So here there is the explanation. And also, for example, this one collects all the paragraph elements in an HTML document. And here it collects body under the HTML. So it goes head element, then one generation forward, body element, and takes all div elements just located after this body element. And this one goes the third div elements and collect all paragraph elements inside. And also we can also specify our XPath using attributes as shown here. Specifying attribute is another way of navigating our XPath over the HTML document. And here, sorry. Yes, here we have some other examples, and let's explore some practical XPath examples. To collect all children of a specific element, we can use the XPath HTML body and star. So star just collects all elements in of a specific, all children of a specific element. And if you want to collect all descendants, we should use /star. And if we want to collect all elements in the entire HTML document without specifying any element, we can just use / and star. Then it will just extract all the elements in the HTML document. Here there are some symbols, so we can just use those symbols to navigate ourselves through the HTML documents. And there are some further examples. You can work on it on your own. There is this HTML code here, and to find how to get access, thanks for watching text, what should I do? You can work on it on your own. And also we have CSS locator. CSS locator is just another language, just like XPaths. And so it provides an alternative way to locate elements within an HTML document. And so we have here a period for class, a pound sign for ID. So for example, here p.class1 selects all paragraph elements belonging to class 1. And if we want to go, so we just the notation changes, then all remaining idea behind are similar with XPath. And so after I will just stop here, but if you want, you can also go over spider section here. Spider just works to do all of these operations faster than basic Scrapy. But for this session, I will just stop here. And let's go through the notebook then. Here is the relevant notebook. So if you didn't use previously Scrapy, you can just download it. Pip install Scrapy, please, before import it. So from Scrapy library, I'm just calling selector method function here. It's a part of Scrapy library, and I also need to import request to get access the URL, and this is the relevant URL. I just want to collect information about top 250 movies in IMDb list. Let me just open the web page. So I will just scrape the data on this web page, and so in the first as the first thing, I should go I define the URL here, and using this get method, I am just defining this URL and assigning this to an HTML document, and I am creating a selector object here using this HTML content. And by doing so, now this selector object is specifically defined for this web page. And let's go for the source page behind this web page. For every web page, we have source pages behind, and browsers allow us to go and take a look for those web pages. And here you should do is just inspect elements. Click on inspect elements from right hand side. So let's do this. And here we have HTML source code of this web page. These are elements, HTML elements behind the visible part of the web page. And if I want to, so let me get back. Let me just close that section. So to understand what is this, just click on here and inspect the elements. And now it is just painting the relevant part when you are walking around the HTML code, right? So here there are, for example, H4, and yes, this is the name of the movie is written, and I can hypothetically, at least for now, navigate myself through the names of movies. So let's turn back. And here in the last line, let's see on this web page how many elements we have in the HTML document. Let's run this cell and try to see what's gonna happen. Yes, then we have this amount of elements in total in this web page. And this HTML structure has, document has this kind of type. It contains bytes, so you can't do further operations with this document. And here is the type of selector object. It is very specific to Scrapy library. And here I defined an H4 element. So H4 element, so in my the basic thing with pre-structured web pages is they allow very easy ways to access the data that you are specifically looking for. For example, in IMDb web page, it is very easy to get access movie names. Just clicking on this H4 will be enough for you. And so let me just show it to you in a faster way. If I define an XPath here, very short, it will just search all H4 elements in the HTML document. And if I previously know all movie names are labeled as H4, then my job will be very easy, right? So I just define this in this XPath object, and I put this string into the XPath methods here. The input of this function is this string, and I just want to extract the content for this relevant XPath. So here is the outcome. And we have these H4 elements, and we just downloaded all things covered by these H4 elements. Here we have the name of a movie, we have its year here, and we also know now the order of the movie. And here you see. But how to navigate ourselves, or how I found this H4 thing. So let me just show you a tricky thing for this. If you go the relevant part in the web page in the HTML document and right click, sorry. Right click on the relevant part, you will see that there is copy section here. In this copy section, if you go for copy XPath, it will just select the XPath of the relevant chosen part. So if I click on here and copy the XPath, then it will extract the longer version of this XPath location. So here you see this exact position of that element in my HTML documents. And if you compare first, second, third, and fourth movies, then you need to find a pattern among those to understand what kind of general frame can carry me to find my relevant elements, list of elements. So here it is very easy, H4. And so what about how many elements here, how many objects in this list? So it extracted a list for me. Let me try to find how many elements. So it is 250, and there are 250 movies, so it works. What about collecting texts in these elements? Here I have a line. And in this line, in the text part of this line, I have the movie name here. And if I only call the textual part under this element, then it will directly extract the movie name. Let me just define another XPath here and just extract the content for this XPath and assign it to another variable called movies. And in this movies, I have the names of movies. But however, I also have this next line symbols. And to delete those, I will show you a tricky thing that I used before. And in this for loop, I'm just taking each of these. This for loop just covers all the elements, all the objects in this list. And this strip function allows to allows to delete irrelevant parts of my list. So by using this code, I am cleaning my content, and there is a brief reminder here for this. How does this strip function work? You can take a look at it on your own. And this is cleaned movie list. So I have movies, and let me just check the length of it here. Yes, I have. It is 250 as expected. So what about the order and year of movies? So also they are stored in H4 elements. And let's turn back to find that XPaths here. Yeah, I have this content. And in this content, I have one span here, then textual part, then second span here. Yes, and the end. So there are two spans. If I go for the first span, probably I will see this part. And if I go for the second span, then I can get access this part. So let me just do it here. And let's go one children of this H4 elements, and then take the textual part of this element, and it will extract the order. And if I go to second span element, then it will just extract the year of the movie. Let me run those as well. And I also defined movie order and movie date in the same order. And also movie links. So links are always stored in this A elements, and href attributes under the href attributes. It's another universal thing. It might be good for you to remember this. And if you just go here, probably there will be somewhere the links stored. If you take a look at it, there should be some A. Yes, I see A here. And let me try to see where this A opened. Yes, it is opened here. And there should be an href attribute in this element. Yes, here it is. So I just want to get access this place, right click, copy the XPath, and try let's paste it here. So yes, this is link for first movie. Here you see, so I just copied links for movies here. This is for the first movie, this is for the second movie, third movie, and fourth movie. So the only thing is changing is the orders of divs, right? 1, 2, 1, so 1, 1, 1, 2, 2, 1, 2, 2, then there will be 3, 1, 3, 2, 4, 1, 4, 2, or that kind of thing. So if I just ask to collect all divs in the same order and then go for A elements and take the content of href attribute, then it will extract the exact links. Let's run this cell, and this is movie link. So we have 250 links here. Let's see what we downloaded. So we downloaded this kind of thing. So this only downloads, let me open the link now as a normal way. So let's, yes, here I have Shawshank Redemption webpage in IMDb, and you see the link, right? And here I have the link, but only unique part of this link is stored by my Python. So the Scrapy only downloaded that part, and because the other parts are totally generic, but if I want to call this web page back, and if I want to walk around those web pages in a for loop, then I should just construct this the combined, the merged version of those links. So for this reason, in a for loop, I'm just adding the first part and the last part, combining these two with the unique part, which is downloaded by Scrapy. And after that, let me just run those cells also. And so after that, I have relevant links. So what about how to save this data? I suggest you to save it in a dictionary, but there are multiple ways. Then I will just turn it to a Pandas data frame. So this is movie order list, movie date list for the years of movies, the names of movies, and also the links for those movies. Let me just run this code. And so I call Pandas library to transform this dictionary object to a data frame. And here just define a data frame. And let me see. Yes, this is my data frame. I just have the order of names, movie, the year of movie, the name, and the link. So let's call first movie link. It is just like that, right? The same link with this one. So for example, if I want to go further, then I can just define this URL. For example, for this page, let's turn to 0. So for this page, I defined a new URL and go request an HTML contents here, there, and then create a new selector object and try to see. I didn't define URL, sorry. Yes. So this is very much, so I think I didn't run something, I think. Yes. Let me just open the web page here. And let's see how many. So let's open. It doesn't allow me to open the inspect section here. Yes, I can. So there are much more than 6, as you see here. But let me just define this URL manually. Yeah, probably there is the web page is under construction as far as I understand, because I just noticed that kind of warning in the web page. But there should be more than 6, as you probably imagine. And by doing so, I can just go for example, players of the movies to download their names. And just in the same order, I need to create a for loop for different URLs for the links of these new web pages. And then I can search for players. And in the notebook that I will share with you, you can find that kind of exercise. And also, if you want to make this thing faster than this, because in a for loop, going for more than 10, 20 web pages, then this will probably load too much burden on your computer. So for this reason, we use class-based structures. Spider works in that way, and there is a great explanation here to so make you familiar how this Spider framework works. And so you can also try to do same with Spider, and you can get access all of these materials on your own. So yes, that's all for this video, and thank you for your attention.